And we're rolling. So here's what we'll calculate. We're going to calculate the time for the basketball to rise and the time for the basketball to fall. The basketball leaves the ground with a speed of 3.4. So here's what I mean by the time to rise. The basketball starts on the ground, goes all the way up, and it reaches max height. Now I know it wasn't descriptive in the problem, but that's what I mean by the time to rise. The time to go from the ground all the way to maximum height. So, like we said, Vy initial is 3.4. That's all that was given, and we need to figure out the rest. So, let's start with the easy one. What's A? Easy. A is negative 9.8 meters per second squared. Do you know anything else? Displacement was 0 before, but now it starts on the ground and ends up here. Yeah, just straight up. So it doesn't go all the way down yet. So we've changed the positions here. All of a sudden we have a different final position and initial position. So here's the scenario. Starts on the ground, ends up in the air. So at maximum height, our velocity is 0. Maximum height is our final position. We're timing how long it takes to go from the ground to maximum height, and at that location, our velocity is 0. And that's it. We've got 3 numbers. We're ready to solve. We are. Here's our equation. Vy final equals Vy initial plus Ayt. So 0 equals 3.4 plus negative 9.8 t. There's 2 different things I can do to solve for t here. What do I do first? Either one, really. We could subtract 3.4. That's one way. Subtract it on both sides. Cancels. And now divide by negative 9.8. I'm not going to show that step. I think, you know what's up. .347. Nothing exciting about that. Not until part B will we find something out about this. So, questions there? Pretty straightforward. All right, part B. We're changing our scenario now. So on our example before this problem, we started on the ground, ended on the ground. On this example, we started on the ground, ended in the air. But for part B, we start in the air, ball falls to the ground. So this takes place after it has reached max height. It reaches max height, and gravity brings it back down. Speaking of gravity, well, we know Ay is negative 9.8. At max height, what's our velocity? 0. So Vy is 0 meters per second. In a second, we'll have to figure out if that's initial or final, but let's just get to this last part. It left the ground with a velocity of positive 3.4. So what does it return to the ground with? Negative 3.4. And that's all the information we have. One of them has to be initial, one of them has to be final, and it's pretty, I mean, in my opinion, it's clear. What do you think? Which one's initial? The top one, the 0, because it's falling back down. This is our final down here. Same equation. What's up?
Why is the final velocity 93.4? Because isn't it
When we talk about objects that are falling, we never, like, it'll be 0 after it hits, but we're going to look at it. It's kind of convenient that I did a crappy drawing here because we're looking at it just before, when it's like a micron away from the ground. So it hasn't stopped yet. It's still moving. It's about to slow down. Solid question. Plus, if it hit the ground, the other thing is, like, if I drop a bowling ball on your foot, is it going to hurt? Yeah. Because it's still moving. So the whole, like, bowling ball hitting your foot, that's a different problem. That's a little different than the gravity problem. So let's plug these in. Same equation. Did anyone solve it yet? Did you get a number yet?
Yeah.
What is it?
It's the same number.
Same number.
Oh, because you said that it speeds up the same when it goes down.
Exactly. Because it has, it's going to change speed at the same rate on the way up as it does on the way down. So we're going to have the same time. So that is our last fact that we need to write down. It's also a fact we need to memorize. So the literal fact of the matter is the time it takes for an object to rise a certain distance is the same as the time it takes that object to fall the same distance. So here's how I wrote it before. I think it was too lengthy of a way to write it, so I'm going to write it in a shorter way. So here's the literal way to write it. I'm going to change it. I'll write a shorter one. The time it takes to go from the ground to max height is equal to the time it takes to go from max height to the ground. So the time it takes to go from here to here is the same time it takes to go from here to here. But I think we can kind of dance around that, make it a little easier. Write this with your bullets from before. Here's how we can say it. Time to rise is equal to the time to fall. Ugh. That's crappy too. But we're not perfect. So time to rise equals time to fall. That's something to memorize.